All right, we had a quiz halfway through that covered digraphs and tournaments, plurality and pairwise, board account, and runoff. Some of those skills are going to be readdressed in this test because our first lesson in the second portion was our lesson on defects of voting. But to test defects, we have to actually do a voting method. So those 4 voting methods will be addressed again. We will not directly address the ideas of tournaments. You will not have to construct a preference table, but you will need to be able to do plurality, pairwise, borda, and runoff. Not necessarily all of them, but any of them are fair game.
Wait, we did.
So they were on the quiz already, but they will be possibly on the test again. Maybe not all 4 of them. They were all 4 on the quiz, but some of those voting methods will show up again. You should also understand that they aren't perfect, and that's actually what Arrow's impossibility theorem says, which is something that we talked about in the first lesson on this one with defects of voting. The Arrow's impossibility theorem says there's no perfect way. Every single voting method has the potential to have one of those defects of voting, which fails one of the 4 fairness criteria. So, the first new bullet point says, understand the 4 parts of the fairness criteria and how they are violated by one of the voting methods. So, our 4 are majority. Majority says if more than half of the people vote for somebody, that person should win. The next one is Condorsets. And Condorcet says if somebody wins in head-to-heads, they should win. Technically it says if a candidate can defeat each of the other candidates in a head-to-head vote, then they should be the winner. So Condorsets is something that's favored by pairwise, but the other ones could not match. So make sure you know what Condorcet says. Okay, so Condorcet is a head-to-head winner should be a winner, or a mini battle, as we called it. No. The next one is the independence of irrelevant alternatives, or the IIA. The IIA says if you delete a non-winner from the ballot and conduct the election again, the same thing should happen because they weren't a winner anyway. Okay. So independence of irrelevant alternatives. Irrelevant means it's somebody who shouldn't have made a difference because they weren't a winner. So if you take out a loser, the winner should still be the winner. But that doesn't always happen. And then the last one is called monotonicity. And that says if some people end up changing their votes in a re-election to favor the person who won the first time, then that person should still win because they're getting more votes. So in theory, it would seem like that should happen, but it doesn't always happen. That one's the weirdest one to me. It really seems like if you're favoring somebody, that should help them, not hurt them. Okay. So make sure you know what those 4 things mean. I won't ask you to list them, but in a question it might say, given this preference table, conduct the election with a board account. And then it might say, does this violate Condorcet's fairness criteria? And so then you would have to know what it means to do Condorcet and how you would test for that. Condorcets you would test with a pairwise, and your pairwise winner should be the winner according to Condorcet.
Okay, so you would do borda, and then you would do runoff, I guess?
You would do pairwise. Mm-hmm.
And then
Yeah.
if they're not the same,
Then it's violated.
okay, because so the IIA is like runoff.
Yep, the IIA you would test with a runoff. And Condorcets you would test with a pairwise.
majority with plurality.
Yeah, majority, you would look at whoever got more than half of the first place votes. And then monotonicity, you would redo using the exact same method you did the first time, but you would have to alter some of the votes according to however it tells you to alter them. But you would use the same method as you did the first time.
For monotonous.
For monotonicity, you would reuse the same method.
But then, like, what do you do with that?
Some of the votes it would tell you are changed. So it'd say like these 3 people changed their votes from ABC to BAC. Does that change the outcome of the election?
Oh, so you just have to test it.
Mm-hmm. So you would just like do the problem twice with the 2 different pieces of information. And theoretically, if they're changing to favor the winner should still be the winner. All right, so that is the 4 parts of the fairness criteria. So that is this one. You need to understand what the weighted voting system notation is, so that when you see like brackets, 24, 10, 8, 5, 2, you know what that means.
What does that
The
mean?
biggest one we
Okay.
have is 3, right?
Well, on this, you just need to know what each of these numbers mean. So I'm not asking you to necessarily create anything for this, but just to say that 24 is called the quota. That's how many votes it takes to pass. This shows me that there are 4 voters and their individual weights of voting, 10, 8, 5, and 2. You should know what a dictator is. A dictator is a person who has enough power to control the vote completely alone. So a dictator would be a person whose individual weight is equal to or greater than the quota. And you should understand somebody who has veto power. And somebody who has veto power is somebody who can, even if everybody else agrees and that person doesn't, that they can veto the vote. So that would happen in this one, that people B, C, and D, even if they all agree, they only have 15 votes. So person A has veto power here, because no matter what, person A has to agree to get it passed. In reality, I think actually they all have veto power, because it doesn't, yeah. So I picked kind of not great numbers. But in reality, in this problem, I guess they all have veto power. Even though they have different weights, everybody's vote actually really matters.
So is that like a pivotal voter kind of?
It's a little bit different than the idea of a pivotal voter, because in a pivotal voter, we care about the order they're placing their votes.
Okay, what was the other one?
Critical.
Okay.
So it's kind of the same idea of a critical voter. If we're considering the coalition of the whole group, then it's the same idea as a critical voter.
Because you have to test it without the one person to
Mhm.
find out
If there would still be enough.
if they're veto.
Next one says be able to find the winning coalitions in a weighted voting group and be able to find the critical voters in those coalitions. I promise I will only give you a voting system of 3 for this, so there will not be tons of coalitions, okay? But remember, coalitions involve single voters, pairs of voters, and then, since I promised 3, just groups of all 3 of them agreeing on something, okay? Coalitions involve singles, pairs, groups of 3, if we had more than groups of 4, groups of 5, etc. Being able to figure out if it's winning, we would add up how many points they have and see if they have enough points to win it. And then the critical voter in the coalition is if they would drop out, do the other people still have enough to carry it without them? Okay. You can kind of use, because we had these 2 different voting systems, try to use some alliteration to help you remember what things mean. So remembering that coalition goes with critical, okay? Coalition goes with critical. They both start with C. And we use that, and this isn't alliteration, but for the BANSAF. Okay, BANSAF is where we care about coalitions and criticals.
What's a coalition again?
A coalition is groups of voters. And it could be, so like if I had 3 people voting, my coalitions would be A, B, C, AB, AC, BC, and A, B, C. It's the different groups of people who might vote yes. So maybe A is the only person who votes yes, maybe B is the only person, maybe C, maybe A and B both vote yes. So it's different possibilities of who could be voting yes.
And then to find the winning one, they have to add up to the quota,
Yes.
right?
Yep. To tell if it's winning, we would add up how many votes they have together and make sure that it's more than the winning. And to tell if they're critical, we say if they drop out, can the rest of the people still carry it or the other person still carry it alone?
And then to find the number of coalitions you'll have is 2 to the n
Yep.
minus
To
1.
the n minus 1 gives you how many coalitions you should have. To compute their power index then, you would look at how many total people are critical, and you would do how many times that person is critical over the total critical. Okay, Banzhaf is individual critical over total critical. So when we find critical, and this is really random, so this probably isn't even possible, but let's just say that like this was a winning one and A was critical, this is winning and A is critical, this is winning and C is critical, this is winning and nobody's critical. Okay,
So it'd just be
so then our denominator would be 3, because there were 3 criticals. A would have a power of 2/3, C would have a power of 1/3, and B actually doesn't have any power in this election. Okay. So Banzhaf is individual critical over total critical. Then being able to find permutations of a set. Permutations are the tree diagrams. So that's where we consider what order the people are voting in. So then we're thinking about like a board meeting and them sitting around the table and going around the table and saying yay or nay all the way around. Okay. So permutations are the order of the voters. And so those would all use every single voter, and it's just in all the different arrangements of them. And again, some alliteration. When we care about permutations, we care about pivotals. Coalitions, we care about criticals. Permutations, we care about pivotals. And the pivotal voter is the voter who makes it pass. So that as they go through an order, whose vote is the deciding vote. And the Shapley-Shubik is the number of individual pivotals over the total number of pivotals. Okay. And every permutation has a pivotal voter. And just one.
Wait, individual, I know how to do this, but just refresh me. Individual pivotals over pivotals.
So for the pivotals, like if I have my A, B, and C.
Yeah.
So my permutations would be A, B, C, that's a weird B. A, C, B, B, C, A, B, A, C, C, A, B, C, B, A would be my different permutations. So then I would figure out who's pivotal in these, whose vote is the vote that makes it pass. So maybe B here, C, A,
This is
and
done with the tree one, right?
yep,
But, and then it would
and
be,
B, and I'll have B, okay? And then I would do how many times was A pivotal, so I had A pivotal once over 6 pivotal people.
Okay.
B
'Cause on the homework-
is 4 over 6, and C, and this is 1 over 6.
And they should all add up to.
And they should all add up to 1.
but there was one on the homework that it was like you said, C didn't get any. But it had 2. It was circled twice. What?
It should have been. If it had a power index of 0, it never would have been circled. Alright. Okay, so that is for the test tomorrow. It is a fairly short test. It's a little bit more quiz-ish than test-ish, but it's at the end, so we're calling it a test.